attendance 81 orang. Sampai terlebih kuota, sampai duk tolak-tolak lagi kuota tu jadi 81. Nak tunggu saya keluar QR code baru ada attendance tu Okay, last class, oh not this one, we stop at here, am I right? Okay. It was dia bukan summary lah, dia sebenarnya ni brief information on how speed control of separately excited DC motor can be done. Okay, so it says that by refer, mana saya punya dia tak highlight yang ni set measure pens yang ni. Okay. By referring of this equation, okay, we can see that the speed of your separately excited DC motor can be controlled with 3 parameter ataupun the other words is the motor speed is a function of the following 3 quantities. Maksudnya you can control the speed of your DC motor by using 3 parameters ni lah. First, okay, for the right colors. Okay. First, you can control with additional armature resistance. Okay, mana nombor 1 ni? Yang ni, okay. So you can add additional resistance here. So if you add additional resistance, look at this question. Okay, so the higher the armature resistance will have an effect of, no, sorry. Since the separately excited DC motor, okay, if you add another resistance, okay, in series with armature resistance, we call it additional armature resistance, Rx ni, this Rx, okay. Since it's in series, so the total resistance for this armature circuit, just summation of Ra and Rx lah, okay. So the total summation will be the new Ra for that particular additional resistance, okay. With the additional resistance, you might vary the speed here. Okay, this is your EA. Okay, so we have your motor speed here. Okay, it will vary according to additional resistance have been added to the circuit. Okay. Next, you can also control by changing the terminal voltage, number 2. So this one. So by changing terminal voltage, okay, what you do is we can take a look on here, previous example here. Example 2, kan? Okay, you can see that with the value, initial value 600 here, okay, 600 here, you have one slope characteristic or speed versus current characteristic of your separately excited DC motor. Okay, when you reduce the voltage to 60 volt here, you can see that you have reduced the initial or the no load speed of your motor as well as the starting current. Okay, in the same time, your motor speed, if with 600 volt, it have one value, speed 1, it will also reduce to new value. Okay, this one is benefit for a what? Low current or low torque with low speed application. Apa contoh motor yang kita boleh pakai, what kind of example that we can apply for this low current and low speed? Siapa tahu? Low current and low speed application. I asked my chat GPT. It says that motor applications such as power window, low torque kan, dia akan turun pelan and it need torque lah, low torque, just a small torque to increase and decrease, incline or recline your window, okay. Your Lamborghini car tu kan, dia pakai low torque and low speed lah. And then conveyor belt system or food processing, okay. Kalau sebab food, dia punya load tak berat lah. Contoh macam bulan-bulan puasa ni biasanya fikir apa? Ice cream, right? Okay, so packet ataupun batch of ice cream yang one by one tu, kalau tengok kat YouTube kan banyak ice cream punya manufacturing process kan. So it's just a light load, ringan je kan, okay. So dia tak perlukan high speed, terpelanting habis dia punya ice cream tu, okay. And it just need a low torque to move batch of the ice cream from one station to another, right? And then you can look at on gate, automatic gate kan. Torque dia depend how big is your gate. Macam mana je pun gate you kalau nak compare dengan crane. Crane kan dia one time kan. So gate ni just not as big as high torque macam crane pakai, macam container, yang angkat container tu high torque lah. Okay, so macam automatic gate nanti dah jadi IR, dah jadi apa tu, datuk kan, so rumah rosak, so you have a very big gate kan, takkan buka manual, takut malah pakai automatic gate, tak adalah pasal hujan kan. Okay, so bila ada automatic gate, you need to install motor lah to control, you nak buka slide ke, you nak bend your gate ke, ataupun sliding left right kan, so dia kena pakai motor. So that kind of motor pakai low torque, low speed application. Okay, okay, so itu untuk contoh dua ni. And next, tadi kita control voltage, okay. In spite of reduce this daripada from 600 to 60, you might also increase, okay, tapi increment of voltage from a rated value, dia bahayalah sikit because dia akan exceed, dia akan dibayangkan when you increase this value, you will project your slope ni, this slope to this one. So you might have a higher starting current, which might not, which cannot be bear by your motor or by your drive later. Okay, so dia tak, not really suggested to increase. Biasanya untuk case voltage control ni kita reduce lah most of the time. Okay, next, let's see, another method of speed control is by adjusting the field flux. So the field flux nanti kita akan tengok contoh later. Usually untuk field flux kita akan adjust by adding or adjusting this RF. You might have an adjustable field resistance, or you might also can adjust the VF. Okay, because you have this one LF. Okay, how much VF supplying the LF, it will affect this speed, your motor speed, but not in proportionally. Dia inversely proportional effect to the motor speed. Nanti kita tengok the equation dulu. Okay, before we proceed with this adding armature resistance, okay, in detail, so let's start with example first. In the middle of the class, we will, okay, it's already 70, I think good enough. Okay. Kita akan mark your quiz, okay? Your quiz, saya akan share, I will share the file, okay? So you will pick your friends, tolong tak perlu saya assign kot. You will pick your friend's paper and mark. So I don't know, you nak download, mark and upload balik, ataupun kalau you have plug-in application on your drive, macam you might use kami ke annotation punya panggil apa, plugins, you boleh terus marking di that particular folder. Ikutlah macam mana, janji nama orang lain, yang mark orang lain. Okay, saya akan key in markah based on the marks on the paper lah. Okay, so I hope you have pen and paper with you. So let's proceed with example 3. Example 3, it's still using the same example 1, okay, initial lah, so that it's easier for you to make a reference from example 1 to example 2. Example 2 kita buat apa? We change the VT, right? So let's take a look. Untuk example 3, what should we do? Example 3 here. Okay, if you have any question, don't hesitate to interrupt my lecture, okay? And I noticed there's few students from other group also. Okay, thank you very much for joining the class. Please sign on the attendance too nanti, okay? Okay. Assume that the starting current of DC motor must be limited to 6 times. Dia sama je. Example 2 dia cakap apa? Starting current limit to 6 times. Okay, sama. Okay, next. Show that, oh tadi 6 times. Show that this can be achieved by adding resistor. Oh, okay. Example 2, kita adjust armature. Okay, now let's change the method. We are not adjusting the VT or VA. Now we adding one more component on the circuit, which is the by adding a resistance to the armature circuit. Okay, and now you need to sketch new one. Then number 2, you need to sketch the new speed current characteristic of the motor. So 2 tasks. Okay, so let's start with drawing your circuit first. So this is your separately excited DC motor, your RA, your RA add, because you are adding one more resistance, add additional, R add, and then your LA, your EA, and this one is your LA, negative, EA, this one is your VA. For field circuit, you have RF together with your LF. Okay, ini this one just DC motor semata-mata. Kita tak ada drive lagi. Okay, ni macam mesin lah yang belajar dulu, sama je kan? Okay, next, what should we do is apa dia punya parameter. Okay, example 1. Okay, masih sama. So you still have your kV equals to 3 volt second. kV ni what? Your motor constant. And then your VT 600. Okay, tak kacau VT lah. But we add another component with additional resistance. And then RA, your RA is 2 ohm. I rated here. IA rated is 5 ampere. And then, okay, itu saja. Now, how can we achieve this one? starting current of the DC motor must be limited to 6 times of the rated value. Okay, originally this is your slope 20 and 300. So without additional resistance, this is 200 radian per second. Your motor speed, the no load speed of your motor. And this one is starting current, 300 ampere, right? 300 ampere. And what else? That's all. Then this one is with V equals to 600 and just RA. Okay. So now what happened if we add armature resistance, additional armature resistance, kita set dia punya new criteria first so that you tak confused. Your IST new I starting current kita starting current ni. Starting current, new starting current must be limited to 6 times of the rated value. So IA rated kali 6. Sama lah macam itu sebenarnya. So this is 5 times 6 equals to 30 ampere. Okay, now from 300 dia punya ni starting current, new starting current is 30 amp. So this is IST new. This is your original starting current. Okay, so how? Let's dia pakai circuit ni je sebenarnya. Your loop of loop 1. So loop 1. Take the Kirchhoff voltage law. Negative VA plus minus plus minus plus minus, right? So plus IA RA plus RX in series kan? In series, so campur je. Plus EA equals to 0. Okay, so now you nak cari what is the value of RX sebenarnya. Okay, yang boleh, yang that can give, you need to find this RX that can give starting current 30 amp. Tu je sebenarnya task you. Okay, so now let's find the RX since everything is given. Okay, starting current, starting current is this is your speed, right? This is your omega naught. This is, oh no. Okay, so this is speed at starting. Okay, so at starting, speed dia equals to 0. Okay, from this equation, your EA equals to KV omega. And since we are talking about starting condition, we can say that this speed is 0, which make your EA is 0. Okay, straightforward je ni. Okay, starting condition, speed 0 here, your EA pun automatically 0. So now what left on your equation is VA equals to IA RA plus RX. Senang je. Okay, so now rearrange your additional resistance. V per IA minus RA. Betul? Okay, kalau salah beritahu kalau salah jangan sesat lah sepanjang semester. Okay, so we have your VA here 600, we have IA here 5 ampere. Kita nak ambil 5 ke kita nak ambil 30?
30.
Ya, Betul ke sini? Kita ambil 30 because yang ni adalah starting condition. So starting condition, starting lah. Okay. So kali ni kita akan ambil yang ni ataupun kita akan ambil yang ni. So now, why you tak confused, yang ni adalah IST new. This one. ST new. Okay. So it's 600 over 30 minus 2. And you will have your additional resistance. Berapa ni? 18.
18.
Thank you. 18 ohm. Okay. So, cerita dia. So, when you add one more component of the resistance inside your armature field, armature circuit, okay, penambahan this additional resistance, the more the resistance, the current will be tinggi ke rendah? V sama dengan IR.
Tinggi.
The more resistance, the more the V. So let's take a look on the V, the more the V, but nanti you tengok balik ni, equation ni. Okay. Kita tengok dekat graph dulu. Okay. With this additional resistance, nilai dia 18. Okay, kita tengok, let's check the no load dulu. The no load, yang ni, ada changes tak? So, the no load speed for the new condition, untuk example 3, kita example 2, omega naught 2. So, yang ni omega naught 3 lah. So that you boleh differentiate. Omega naught 3, apa? Speed equation. Speed equation dulu lah. Speed equation adalah Vt over Kv minus Ra Td or tak apa, satu lagi saya tulis Kv square, or second term or the second formula that you can use is Vt over Kv RAIA Kv. Okay. So this first term is your omega naught. The second term is the speed drop of your motor. Okay. So we would like to find the omega naught 3, the new no load speed when we add this additional resistance. So it's Vt over Kv. Okay, Vt is still the same, so 600. Your Kv is also no changes since you are not changing any motor there. So 600 over 3, you barat akan dapat the same 200 radian per second. Okay. So this will also share with omega naught 3. And if you look at example 2, omega naught 2 adalah 20 radian per second. So okay, this one, scale saya tak betul, tapi kalau you draw, you better guna scale yang betul lah. So ini adalah omega naught 2. Okay. Kalau saya draw, yang ni adalah case, tak sama pula. Dia sepatutnya parallel. When you change the Vt, this one is parallel. Okay, so this is 20 radian per second. This one is with V, apa? 60 volt. Okay. Now for VO3 pula, for additional resistance, okay. So additional resistance, tadi we calculate that this one is 200 here, and point for starting current is here. So your new slope is this one, okay, and this one is P same VA, but RA plus RN. Okay, so ada two situation di situ, two condition di situ. Okay, sketch the new speed current characteristic of the motor. So the answer is sebenarnya macam ni lah. This one, the original one, 200, your speed, your current. This one is 300, your initial starting current. And then with 30 ampere, your IST new. Yet you are having the same no load speed. Okay. Let's say this 200 radian per second is kita classify, let's say lah, kita classify it as high speed. Okay, so you can reduce the torque on initial here, reduce the torque and current. Okay, the lower the torque, the lower the current. Okay, reduce the torque, but in the same time you might achieve you might have high speed no load condition. Okay, this one is for example 3. Right? So this one is one answer, and this one is the justification or the calculation of the formula. Now, for example 4, let's go to example 4 first. Okay, for example 4, now kita tukar motor. Tadi previously we use separately excited. Now give you 150 volt DC shunt motor, drive a constant load at speed of 1200 RPM. The armature field and resistance, dia kira sini, armature field and resistance is 1 and 150. Okay. The motor draw a line current of 10 ampere. Kita suka dia punya drawing sebab macam terlengkap. So I prefer to draw my own circuit. Okay, shunt, so dia parallel antara field and armature. Okay, it's 150 volt. Sekejap ya, traction. Okay, let's proceed. Tadi 150 volt. Okay, DC shunt drive a constant load. So we have a speed here. Your N is 1000. When it says RPM, so you need to use N. Kalau yang ni N. Kalau dia adalah 1200 radian per second, yang ni adalah omega. Okay, tu dia punya beza. Next, the armature and field resistance is 1. So this one is armature 1. Field resistance is 150. Okay, next. The motor draws a line current. Okay, line current ni kat mana? Line current is from the source. So this is your IL. 10 ampere. Okay, respect at the given load. Okay, so now calculate the resistance that should be added to the armature circuit. So we need to add R at here. Ini your R, sorry. This one is LA, RE, RF, LF. This one is VT. Okay. Calculate the resistance that should be added to the armature circuit to reduce the speed by 50%. So now, the new speed N2 is need to be reduced by 50%. Now speed, so 50% of 1200 multiply. So 0.5 1200 is 600 lah, bagi 2 je. Okay, this is your new speed. And okay, by reducing this speed into 600 RPM, what is your RF? Betul. Calculate the resistance that should be added to the armature circuit to reduce the speed by 50%. Okay, itu soalan dia. Okay, where should we start? Okay, we already have circuit. Okay, let's start with what else can help you is your graph. Okay, so this is your graph. Okay. Let's say this one is the original. It says that dia dah ada set its own current. Okay, so this is your motor speed. This one, to speed 1 is 1200. Okay, and then 50%, maksudnya bahagi 2 lah kan. So from here to here, bahagi 2, approximately here. It's not omega, apologize. It's what? N. And N1. And this one is your N2 with 600 RPM. Okay. This one is your current. Okay. Next, kita tengok armature current. Armature current. This loop. Okay, kalau you involve dia punya VT, and another one is here. Some reference is also mentioned or recognized line current as motor current. Motor current means motor current that supply to the motor current. Okay, dan motor current ni ada 2 pula. IM, this one is IM, is summation of IF and IE. Okay, F plus IE. Okay, so if we like to find IA1, lalu yang tu, saya bagi satu equation dulu. Okay, ini equation 1, and then let's make a ratio. Ada kan masa motor pun kita, masa mesin pun, electrical machine pun kita ada pakai kaedah ratio kan. Let's use that method. Speed 1. Speed omega n1. Your BEMF is equal kV omega, right? Okay. When you have two different speed, okay, let's say speed 1, you have EA1, okay, and if you have speed 2, you have your EA2, okay. When we use a ratio method, okay, kita boleh pakai because they are sharing the same motor construction ataupun motor constant. So we can strictly do A1, KV omega 1, A2, KV omega 2. Okay, kita boleh cancel this one since it has the same value. So now this omega 1 and omega 2 is the same, it's not the same speed, it's the different speed but sharing the same motor with a different BMF, okay. And since we are using this RPM, so we can strictly change it to N1 over N2, okay. Next, let's take a look on the motor speed equation, okay. Your motor speed equation is ini number 2, Vt over Kv minus Ra Tb over Kv squared. Sekejap Okay. Oh, I forgotten about the loop. This one. Kita pergi loop number 3 first. Yeah. Okay. This one, you have this EA, right? EA1, EA2. So from this EA, we can expand the equation from where? From this loop. Loop 3, okay. Negative, positive, positive, negative, positive, negative. This is your EA. Sampai sikit, okay, nampak. Positive, negative. Okay. So tengok, ambil loop ni, loop yang from VT go through the armature circuit of the shunt and go back to the VT. Okay. From loop 3, you can write out VT equals to IA RA plus RX plus EA. Okay. This one is the second condition, which is your EA2, IA2, VT is still the same. Okay. 2 means new reduced speed lah. Notation of 2 ni, okay. So kalau untuk 1, IA1, RA, no RX. Okay. Originally with 1200, there's no RX, only RA. So plus EA1. Okay. kita sebenarnya nak replace this EA2 and EA1 on here. Okay. Okay. From this equation, rearrange your EA. EA2 equals to VT minus IA2 RA plus RA, and EA1 equals to VT minus IA2, sorry, IA1 RA. Okay, and replace EA1 and EA2 on equation 2. Okay. We will have ini equation 2. So EA1 VT minus IA1 RA over EA2, this one, VT minus IA2 RA plus RA equals to N1 and N2. Okay, next. What else we did here? IA. Okay, kita tengok, check dulu. We know what is N1, N2, VT ada, VT2 pun ada sebab dia tak berubah, no changes between VT1 and VT2. RA, so the same. R8 is the one we need to find, IA1 and IA2. Okay, so kita tengok IA1 and IA2. Tadi yang ni. IA1 equals to, rearrange, IM minus IF. Okay, and motor current, this one, and minus IF berapa? Ni, point ni. This one is your IF. Okay. Okay. This is your IF, the one that flowing through field circuit. Okay, so IF here. So this one setara dengan point ni. Okay, this is your VT. So you can say that VT is equal to VF. Okay, and you have resistance here, and strictly you can use it to calculate your field current. So it's a VF over RF and over 150 volt over 150 ohm. So your IA1 is 9 ampere. Okay. And how about IA2? Okay, let's take a look back on your graph. Okay. Since this one is your current. Okay. Yang ni starting current. This one is your starting current. This one is your operating or rated current. Okay. Says that with 1200 here, okay, with IA1 9 ampere. Okay. So agak-agak IA2 berapa? Any guess?
Satu ampere.
Berapa? Kuat sikit, tadi ada orang jawab.
4.5.
Satu ampere satu.
4.5. You divide by 2. Tak. Bukan divide by 2. Sebab yang divide by 2, the one that you divide by 2 is only the speed. Okay. Kita baca balik kriteria dia. The motor draws a line current of 10 amp at a given load. Okay. So now you only need to reduce the speed by 50%. Speed je reduce. Okay. Recall back example 3. Okay. When you add additional resistance, what happen? You will have, okay, keadaan dia, the condition is, when you add dengan ni, example 3. Tak nak perasan. Okay. Okay. So when you add additional resistance here. Without changing the armature. Okay. Regardless lah motor apa pun. Okay. So sekarang ni you add additional resistance but you make no changes on the terminal voltage. Okay. In terms of graph, okay, you expected that you will have the same V but with a different starting current. Motor speed macam mana? Cuba project. Let's say this one IA. This one is for motor speed 1. This one is motor speed 2. So you will have variant of motor speed depend on this starting current punya ni lah. And this criteria is on this RA plus RX. Okay. So additional resistance will basically reduce your starting current as well as your motor speed. So the same concept can be applied to this example. 4. This one. Okay. Since we already know where is the speed. Tadi speed 1 kat sini, speed 2 kat sini. Okay. And we know that this is the no load speed. Okay. Boleh agak tak kat mana point dia? Here. It will share the same armature current. Although dia punya speed is reduced. Okay. Nanti kita tengok. Kita check balik betul ke tak. Okay. So now this 9 ampere is also same as IA2. Okay. And we can replace here. So it's your VT is 150 volt. -150 volt minus 9 times RA1 9 times 1 over 150 volt minus buruk tulisan 9 times 1 over 150 volt minus 9 1 plus RX. Your N tadi 1200 over 50% 1200 or dia boleh jadi 1200 over 600. What else? So rearrange lah. Let's say this one is 150, 9, 150 minus 9 minus 9 RX. Ataupun tak payah kembangkan pun tak payah. Nanti pening pula. RX. So rearrange this equation. Kalau kita nak cari your RX, you will have your RX as 7.83 ohm. Okay. Soalan 1. And B, assume the rotational losses to be 100 watt. Calculate the efficiency of the motor with and without the added resistance. Okay. B, assume that the P apa? Rotational losses. So P rod kan? Ingat tak? P rod is 100 watt. So we need to find the efficiency. efficiency is P out over P in times 100%. Okay, so let's find the P in. Sekejap ya. Okay. Raja muda kat rumah ni, sat-sat tukar channel lah, sat minta ayak lah. Itulah dia. Okay. Okay, tadi dia suruh cari efficiency to compare before and after. Before and after we add the resistance, additional resistance. Okay, so let's recall back your efficiency equation. So efficiency is P out over P in. So can we find your P in? P sama dengan IV. Ingat tak? IV ni apa? I is IM. P sama dengan IV. I ni I apa? I yang from the source, which is your IM, and V is V by the source voltage. So it's your IM with VT. So IM tadi 10 ampere times 150 volt. So your P in is 1500 watts. Okay. So P out. P out apa? P in minus P loss. Okay. Apa information yang kita ada untuk this loss, your power loss. Okay, let's take a look. P loss. P loss, we have based on this one. Okay. Kira whatever losses that you can find only. First, you found that the rotational losses 100 watt. Okay, so and from this circuit, right? From this circuit, we can find two losses, which is losses from RF and losses from RA. Sekejap ya. Okay, PRF and PRA. Okay. So itu dia yang ada. Dia tak bagi apa lagi losses yang ada. We have friction and windage not given and cannot be found on the circuit. And what else? P3 boleh kira. Nak kira pun boleh lah, tapi dalam contoh ni saya tak kira lah. Then what else? Copper losses. Yang copper losses ni lah. RF and RA ni. Jangan saya ingat. Nanti kita tengok dekat slide lagi. Okay. So yang ni yang mampu kita nampak at the moment. Okay. So P in minus P loss. So your P loss will be P in IA square RA. Saya buat macam ni lah so that nampak lebih jelas. Plus IF square RF. Okay. P rod. Yang tadi dia given by the question. Okay. So now let's say B4. Kita kira B4 dulu. So B4 at before additional resistance, before add RF. So your P out equals to 100 watt minus 9 square times RA is 1. Okay. Sedap pakai pen ni. Okay, let's try this one. So your P out, tupai sangat lah keluar asal-asal. P in is 1500 minus IARA 9 ampere square kali dengan 1 plus IF tadi 1 ampere square kali dengan 150 minus rotational losses here 100. Mana dapat 1 ampere? IA is 9. Okay. So this one 9. IM minus IM tadi 10 minus IF. So IF bawa ke sebelah sini, 9 bawa sini, 10 tolak 9, dia akan jadi 1 ampere. By right, yang ni 150 volt over 150 ampere akan dapat 1 ampere. So that's your IF. Okay. Selesaikan, solve the equation, you akan dapat 331 watt. Okay. Now after additional resistance, your P out kosong kot pen ni, dia tak keluar habis dah buat. Ni P out 1, this one is P out 2. P in is still the same because you are not changing the V or the current supply also not changes. Now yang berubah adalah IA square RA plus RF. Equal plus IF square RF minus P rod. Okay. So now 500 minus 9 square
Madam nak tanya.
Ya?
Yang before at yang before at RF tu kan, P out tu kan.
P out ya.
Kenapa saya dapat 1169? Bukan 1500 tolak 9 square, tolak 150, tolak minus 100 kan?
Sama juga. Sekejap saya kira balik. Bukan. Oh ya. Sorry. Losses. Yang ni losses. So 1500 minus 331 right? Dapat apa tadi?
1169.
1169. I think betul. Thank you. So it's 1500 minus 331. Yeah, betul. Thank you. Watts. Okay. So P out 2 is 9. RA tadi 1. RA tadi berapa? RA ni 7.83. 7.83 plus RF1 RF150 minus 100. Okay, so basically 1500 minus 965.23. Betul tak? Yang ni P-out 2. Okay, betul. So it's 965.23. 554, betul tak?
Betul madam.
Okay, thank you. Okay, now the efficiency. Okay. Kita ada P out and PE. So the efficiency before P out 1 over P in, and the efficiency after N2 P out 2 over P in. P in is the same. And 100. So P out 1 over kecilnya this one. Okay, 1169 over P in 1500 500 and P out 2 534.77 over 1500. Okay. For before 77, right? 77, 78 lah. Nah, dia 77.93. 78%. After dia jadi 35.6. 0.66. Dia boleh jadi 36%. Okay. So nampak tak? Oh, it's different from 78% to 36%. Okay. Why? Additional resistance. Okay. Additional resistance on the circuit will add heat. Okay. More copper losses. Okay. So more heat on the machine, it will reduce the efficiency of the operation. Okay. So tu dia punya distinct lah reason due to heat in armature resistance plus dia dah already have armature heat, armature and field resistance punya heat, lepas tu you tambah lagi, yet you will reduce the speed, tapi reduction of speed tu absorbed by heat from the additional resistance. Okay, ada tak cara lain? Ada, nanti kita tengok pula. Okay, now this is example 4. Any questions? So far? You nak break ke nak balik awal? Nak habis awal? Balik dah kan?
Balik awal.
Balik awal, okay. Continue terus saya. Nak lena pun boleh je lena, nanti boleh tengok recorded. Padahal. Okay, let's, I will forward drive dekat your WhatsApp. So please check the WhatsApp. Kita ada drive folder dekat situ. Okay. This one, kat WhatsApp. Okay, dah ada kan? So please, how to know that you are not have the same paper? Sekejap. Tak saya buat based on attendance ni. Okay. Saya set kejap. You pilih nombor based on, pilih nama, sorry. based on audience today. Okay. And I have a list of students that already sent the quiz. This one. Mana? You upload situ by apa Sekejap. Right. Okay, ada nama di situ and ada matrix number kan? Okay, ada nama. Okay. Senang-senang. I have this one. Sekejap. Oh, meanwhile, you can scan for your attendance. Boleh buka di mana ya? Cara saya setting ni dulu. And in case ada soalan nak tanya, lagi saya go through balik. Ada. Okay, can scan your attendance ya. Cara saya nak edit ni. Hmm. Yang empat lebih daripada yang hadir hari ni. Tak apalah. Nanti yang the rest saya mark. Saya bagi link dia. Okay, take a look on your. Alamak, saya dah tutup pula WhatsApp sekejap Nak duduk WhatsApp ni pun bercinta jugalah. Sekejap
Madam, saya nak tanya,
Ya. Apa tanya?
link yang Madam kasih tu kan,
Aha.
tak ada nama semua orang Madam?
Siapa yang hantar?
Macam sikit je Madam.
Link drive tu kan?
Betul?
Sekejap ya. Kalau ikut report, yang hantar adalah disangkut lah sekejap ni. Podcast submission podcast submission 86. Cukup Let's see. Oh. follow. Kenapa tak cukup sekejap saya bagi link satu lagi.
Okay Madam, terima kasih.
Thank you Ain for where to here. Sekejap ya. Kita record and everything dia jadi slow. Saya try. Okay. Kenapa dia find? Oh, kat sini. Okay. I use the new link. And kalau tengok dekat Excel yang saya bagi tu, tak boleh buka pula. Boleh buka tak? Excel tu. Ikut.
Boleh madam.
Boleh, okay. So boleh nampak yang mana nama untuk mark paper siapa. Okay. Saya tak boleh buka sampel ni. Okay, so please pick the paper that you need to mark. Oh, dia keluar macam ni. Tolaklah dia punya ni kalau keluar macam ni. Okay, so kalau tengok quiz owner Abdul Muzil, orang yang akan marking paper dia adalah yang Nafisa. If the quiz paper is owned by Adam Najmi, Wong Shi Liang will mark dia punya paper. So it's depend you nak mark macam mana, you nak download, mark and upload semula dekat folder tu pun boleh, ataupun nanti saya buat satu lagi folder lah yang dah mark so that boleh tengok satu folder saja. Dekat the same folder, saya akan tambah satu lagi new folder so that all the mark paper boleh refer dekat situ Kenapa Asyam Bawadah tak jumpa paper dia ke? Ryan. Okay, by right, yup, dah semua orang boleh jumpa paper
sudah
kawan.
jumpa.
Ya?
Ada, sudah jumpa.
Ada, okay. So saya tambah satu lagi folder so that you can regularly mark quiz So kalau you upload, boleh upload dekat folder mark quiz. Folder tu. Okay, saya akan bagi jawapan quiz.
Madam,
Ya, Terima kasih.
quiz paper untuk Adam Najmi ni saya tak dapat cari.
Tak dapat cari?
Ya.
Adam Najmi hantar tak? Tak dalam kelas. And then Adam ada dalam ni? Hello. Adam Najmi Zul Hakim.
Ya, saya Wan.
Hantar tak?
Saya tak hantar Wan.
Oh, tak hantar. No wonder. Okay, so boleh abaikan Adam Najmi. Selamat tak payah marking. But you can take note on the answer. Apa yang mark Adam ni? Quiz owner. Oh, Wong Wong Shi Liang. Okay, tak apa, you just note down for your own notes lah in case orang yang mark tu tersalah mark ke apa tu kan.
Okay.
Look on the quiz questions. Okay. By referring to find the motor speed for condition in example 1 and example 2 previously and conclude your findings regarding relationship between terminal voltage and no load speed and speed drop. So how to find the no load speed between so it's basically on example 2 sebenarnya. So, nak check if nampak ke tak. It is not on the example tapi it's on the slide notes. Let's go for example 2. This is originate from example 2. Okay, so quiz answer first motor speed for example 1. It's a VT over KP minus RATD over KP square. Simple je. For example 1, VT dia 600. KP dia sama, same KP. Mana KP dia? 3 minus RA 2 times yang ni top is not given but it's give you current, so you need to use this one, VT over KP minus RA IA kV. So RA 2 times IA 5, right? 5. Over 3. So it's 196.6 radian per second. So for speed example 2, same equation, Vt over Kv minus Re, Ia over Kv, and you need to know that this one is Vt1, this one is Vt2. So for your Vt2 is 60 volt over 3 minus Ra2 times 5, and there's no additional resistance on the circuit, over 3. So it's 20 minus 3.3. The speed is 16.6 radian per second. Okay. Soalan tanya apa? Find the motor speed for condition example 1 and example 2. Done. And conclude your finding. And conclude your finding regarding relationship between terminal voltage, Vt, no load speed, and speed drop. Okay, so Vt, no load speed, and speed drop. So when you need to look up on the finding, you can make your own table here. This one is example 1, example 2. So dia nak tahu Vt, no load speed, and speed drop, and your motor speed. Okay. So example 1, your Vt is 600. Example 2 is Vt the 60 volt. Letak unit lah ya. V yang ni radian per second. Speed, initial speed, oh yang ni saya tak kira. So ini 600, 200 minus 3.3. So example 1, 200. Example 2, 20. Speed drop 3.3. 3.3, tengok ni. Okay. And then motor speed. That is 196.6. 60.6. Okay. If you look at this one, boleh nampak lah. Example 1 and example 2 here. Saya draw sini lah. Vt 200 pula. This one is Vt equals to 600. Vt equals to 60. 300. This one is current. This one is your motor speed. Radian per second. Motor speed 1. No load speed 1, no load speed 2. And it has one load here. So ni sebenarnya motor speed. Speed 2. Okay. And dia minta findings. So finding is based on your tables and your graph. So one finding. Lagi saya bagi markah finding dulu Ustaz. Finding number 1. Apa dia? When VT, sekejap Okay, finding number 1. When VT reduce, what happened? No changes on no load speed. Tapi kalau dalam exam or test, tulislah nama penuh. Jangan tulis simbol je saya sebab saya short of time. Okay. No changes on no load speed. However, the motor speed reduce, right? No changes, bukan no changes on load speed. Changes, berubah. No changes. No load speed reduce. Ni example lain. The no load speed reduce and the motor speed reduce. Okay. What else? It shares the same what? This one. The same rated current and torque. Kan dia berkadar terus dengan torque. And what else tadi saya nampak ni? The no changes on the speed drop. Sebab it's have the same parallel line between 600 and 60 volt. Okay. So okay, markah. Tukar merah lagi. Fine. Okay. Equation satu markah. Ini sama, right? This one is exact, the correct value is 1 mark. Correct answer is 1 mark. Okay. But during test, it could be 1, it could be 0.5. Okay, tables. Siapa ada tables, 2 marks. Siapa ada graph, 1 mark. And this one also for speed motor 2, 1 mark here. 1 mark here. Finding siapa yang ada related finding. So this one is 1 mark, 1 mark, 1 mark. So total, total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We make this 2 lah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Cantik. 12 mark. Maximum. Okay. Mark yang mana ada sahaja. Yang tak ada, boleh tolong tulis for your friends so that each of you can refer each other. Okay. So please mark your friends' paper and upload back or leave tanda tangan. Don't forget to tanda tangan. Tarikh, what is the date for today for your attendance verifications, 1 April 2024, and your matrix number. Okay.